first. Okay. So we are in the second topic of Python review, and so far we have seen bullet number 1, and in bullet number 2 we have seen up to slicing and a part of slicing. Hopefully today we'll finish the remaining topics of this chapter. So let us quickly revise what we know. Okay. List comprehensions. When do you think we use the list comprehensions? Okay, yes, to create lists. Whenever you have to create a list, we use list comprehension. How about enumerate? What's the idea of enumerate? Where do you use it? Well, whenever you have to loop over some object, some iterable, and you also need the index. Yes, you also need the index as well as the value. Then we use enumerate. What is the purpose of zip? Zip is helpful when you are iterating simultaneously on 2 or more lists. So if you want to iterate over 2 or more lists, in the same order, corresponding order, then you use zip, because it will give you a list of tuples, and you combine 2 lists, so you can iterate over that. Okay, you can iterate over that. Okay, useful for iteration. How about dictionaries? What is the idea in the dictionary? Yeah, if you want to store the values in the form of key value pair, then yes, you can use dictionaries, where keys are like index. They are unique, and using the keys you can get the values. Okay, keys are not sorted, and you can sort the dictionary by keys or by values. How about string methods? We have seen many string methods in our example, but some of the popular one are like join, okay, replace, okay, and split, and capitalize, strip, and so many things. Okay, so these are some of the popular string methods. There are many, actually. Python has so many string methods out of the box, and you could use all of them. But for data science, some of the methods are used a lot, and we'll see them as we proceed in the following chapters. All right. Then we started with this NumPy library. NumPy library is very useful library for all the scientific, for all the numerical calculations. The NumPy library is based on the, you can say, basic structure called arrays. Okay, array. So we differentiate list with array. Okay, we differentiate list with array. When we say list, it means what? In our course, when we say list, it means it's a Python list. It's a list which is it's a usual Python list. Okay, the list object. But when we say array, at least in our course, when we say array, it means it's a NumPy array. So array and list, in terms of meaning wise, they are the same, but here we are differentiating that. Whenever we say array, it is a NumPy array. When we say list, is the usual Python list. Now, how to convert, how to create a NumPy array? Well, you had methods. For example, you can take an existing list and you could say np.array of that list, and you get a NumPy array. Okay, yes. You can also use this built-in methods. For example, numpy.zeros, numpy.ones. By the way, np is for numpy. Okay, you can import numpy as np. Okay, you have .full, that's good. You have also .empty. So you have so many methods in NumPy that will help you to create the arrays. Okay, and then you also have identity matrix. Yes, so you have so many ways to create the arrays. Now, NumPy array has some additional attributes apart from the usual ones. Okay, and the one that we have discussed are these 3. We have seen the ndim attribute. We have seen the shape attribute. We have seen the size attribute. Ndim attribute for any NumPy array, if you have, let's say, array x1, so x1.ndim gives you, what does it give? If you have array, let's say x1, well, it gives you some number. But what is the meaning of ndim? It gives you the dimensions, whether it's one-dimensional, two-dimensional, or so on and so forth. Okay, it gives you the number of dimensions of that array. How about the shape? Let's say if you have a two-dimensional array, then what will you get in the shape? Well, if you have a two-dimensional array, then the shape will give you, yes, the number of rows and columns. That's right, Naif. So it gives you the number of rows and columns. Okay, number of rows and columns. And even for n-dimensional array, it gives you the number of you can say rows or columns in each of those dimensions. How about the size? What is the size of an array? Yeah, it is total number of elements. Size is total number of elements. Okay, so that's something that we know about the attributes. Oops, this is not what I wanted. Okay, yeah. So now we know n dimensions, shape, and size. Then we had this new thing about indexing. Okay, so if you have a list in Python, a one-dimensional list, it is same style of indexing that you have for one-dimensional array. But if you have a two-dimensional array, let us say you have a matrix. You have a matrix like this, 1, 2, 3, 4, 5, 6. Okay. Now, if this matrix is stored like a list, okay, if this is stored like a list, then how to capture this element? How to capture this element if it is stored like a list? If it is stored like a list, you capture that element like 1, 1, 1. But if it is stored like a NumPy array, okay, if it is stored like an array, you capture it, let's say B is the array, then you capture it like this. Okay, so that is the key difference between a list and array indexing in higher dimensions. In list, if you have a list, it's like a nested list. So if for each dimension you need a bracket. Whereas in the array, you don't need bracket, you need comma to separate. You need comma to separate. Okay. Now that is where we stopped in the last class. So we'll continue from there and we'll proceed. Okay. So any questions, any comments, any doubts before we proceed to the to today's topics? Anything that you would like? All right. Okay. So we have seen in the last class, the indexing example for one-dimensional array. Now we'll take a two-dimensional array, copy from here, and we will do the same. Okay, so let me just zoom it. Okay, this is fine. All right. So now the first question is here, just to come up with a random 2D matrix. And now it says display the first two rows and the first three columns. Okay. So it's a two-dimensional array. So you need only one bracket and you need comma to separate the information of rows and columns. Now the style for each dimension is the same. Same in the sense what is the same like this. You start, then you have colon, then end, of course end not inclusive, and then the steps. Okay, start, end, steps type format. So for each dimension you can write this style. Okay, for each dimension you can write it. So here it says the rows. Okay, so you write nav, but remember if you have 0 you don't have to mention that. So if I say like this, it means it's the first two rows. Okay, 0 and 1, the first two rows. Similarly, for the column, okay, we need first three columns. So column, see, when we say column 1, column 2, it doesn't mean the index is also 1. So you have to be very careful. So the first three column means index 0, 1, 2. Okay, so 0, 1, 2. So 2 is included. That means you have to write here 3. And now when you run it, you get it. Okay, so these are the first two rows and three columns. So it should be 5, 0, 3, 793. Okay. Any questions? Any doubts? Any questions? Any comments? Guys in the class. Okay. Now, how about this? Display all rows. Okay, display all the rows and every other column. So when I want to look at the rows, which side should I look? In this, you have here, like this, right? X2 and then comma. So always rows will be on this side. Anything to do with the rows, it will be here. Anything to do with the columns will be here. Okay, remember that. Okay. Yes. So now here, what to change? What to change to display all rows? Yes. So if you just write colon, you cannot leave it empty, by the way. Okay. So you have to write something. So that colon means start from the beginning and end at the end. Okay. All the rows. How about this? Every other column. What is the meaning of every other column? It means alternate columns. Alternate columns, every other column, it means the same. So it says first this column, then this column. So every other column. Yeah. So now you have to change the step. Step on the column side. So this part, you replace it by change in steps. Okay. So treating rows and columns separately is the key to understand the slicing. So here I'm going to say every other column. So I get the desired result. How about this? Display all the rows and okay, yeah. I think we're in 4, right? Yeah. Display all rows and columns in the reverse order. All the rows and columns in the reverse order. Okay. Let us start with the, again, this one is bit tricky. Is it like all rows and columns or just all rows and only columns in the reverse? If you want only columns in the reverse order, that's how it is. Okay. Only columns in the reverse order. If you want both rows and columns in the reverse order, then this is the matrix. Okay. So you see 5033 5033 7953 7953. So it's everything is reversed. Okay. All right. How about this? Display the first column. Maybe this is an easy one. Display the first column. Where do you think I should change? What should be in the rows and what should be in the column? It says display the first column. What about the rows? It means all the rows, right? Display all the rows. Okay. So first column and all the rows. So all the rows, that's the colon, that's right. And for the first column, you could use 0 and you can get it. That is the first row and all the columns. How about this, question number 6? Display the first row. Yes, that's right. Okay. 0. So that is how you display the first row, first column. Okay. All right. Now let me copy this because you cannot see this now. Yes, actually, that's something it's in the slides. Yes, so if you want to display the first row, I could just display it like this. Okay, so this first row I could display it like this. And now the question of Muhammad was slightly different. Okay, but before coming to your question, Muhammad, for the row or even for any ND matrix for the first dimension, I could just write the index and it will give me that. Okay, for example, that will be the second row. Okay, so if for the ND array for the first dimension, if you can skip the other indices by this. Now Muhammad's question was, can I write it without 0? So can I display the first row without 0? Is that your question? Well, do you mean like this? I could use like this. Technically I'm not using 0 here. Okay, is this something? Okay, so this means start from 0 and end at 0. Okay, so 1 means 1 is not included, so start from 0 and then end at 0. All right. How about this? Display third row elements in order of column 3, then column 1, then column 2. Okay, so you need third row elements in a particular order. So tell me, what should be in the rows and then what should be in the column? What should be in the row? Yeah, row should be 2, which correspond to the third row. Now for the columns, he's giving us specific columns. Okay, so remember, we have seen one way of indexing, which is giving the start index or end index and or the steps separated by colons. So based on the information that you have, you will get the corresponding indexing. Sometimes you can use list as index. Okay, list as index. For example, I could create a list. I could create a list of, let's say, in the same order. So column 3 corresponds to index 2, column 1 corresponds to index 0, and column 2 corresponds to index 1. And then I could use this list as my slicing. Okay, as my slicing. So this is something that you must have seen for the first time, maybe. Okay. So now it gives the columns exactly in that order. So that is the third row. Okay, that's the third row. But column 3 element is 7, then 2, for column 1, then 4. So you have 7, 2, 4. Okay, so you could give the list here, or like some students suggested, but you have to be very careful that columns and index, they are different. Okay, when somebody says column 1, it means index 0. Somebody says column 3, it means index 2. Okay, but you can also give it like this and you'll get the same answer. So if you want to slice based on list as an index, yes, you can do it, but you have to be very careful. You cannot have this list as index on both sides. This will give you pairwise elements. For example, it will give you second row, second column element, first row, my bad, third row, third column element, first row, first column element, second row, second column element. If you have list on both rows and columns, it will give you corresponding elements. For example, that's the third row, third column element. Then that's the first row, first column, second row, second column, 7, 5, 9. So that is how the indexing works. Okay, and then the last question is also the same, really not different. Here he is just asking us, and this is not needed. So this was the code before, and now he says display second and following row elements in the order of columns 3, then column 1, then column 2. So what do you think should happen? And in the row, if you see, he says second and the following row elements. So I want the second row and the following row as well. So where do you think I should change here? Yeah, you could say include index 1 and beyond for the rows. Okay, then I will get this. And then the same order, so 3, 7, 9, 7, 2, 4. Okay, so this is about slicing. Remember, the slicing here is different. You have only one bracket to convey the slicing, and you can use list as an index for slicing. This is something nice. Any questions, any comments, anything you want me to repeat?
Yes, just the last one, the second part of this example.
This one?
Yes.
Yeah, so if you have to slice specific, let's say, columns in a specific order, yani you use this. For example, this means in a particular order. So it goes from index 1, 2, 3, 4, 5 up to n. That's just order. That's it. There's no pick and choose. You start from 1 and all the way till the end. And if you want, you could include the steps, okay, but it will go in that order. But sometimes you might have a specific order. For example, I want column 3 first, then column 1, then column 2, and specific in order. Then yes, you could use this square brackets to get the desired output. Okay, so here it says that column number 3, which is index 2, should be first, then followed by column number 1, then followed by column number 2. Okay.
Yeah, now it's clear.
Okay. All right, so that is about indexing. Now we move to the sorting. Sorting is straightforward. So let me just copy the code from here. So sorting for NumPy arrays is done by this method in NumPy, which is NumPy sort. Okay, NumPy sort. So in this example, I'm just creating a 1D array, and I'm printing the array, which is here 503379, and the corresponding original indices. Okay, the indices are always starting from 0, 1, 2, 3, 4, 5. This is always the case. Now to sort the array, I'm using this method, np.sort x1. Okay, that's the only method. Why do you think I'm using toList? I think we explained this in the last class, right? Sometimes I'm using toList. Why is this being used? Yeah, to print it as a list. Okay, it is not changing anything. It's just printing. If I remove that, this is how it looks. Okay, this is how it looks without the commas. So just to have the commas so that it looks the same format, easy to read, I'm printing them as lists. Okay, so that is the sorted array. You can see that 0, 3, 3, 5, 7, 9. That is how it's sorted. Now sometimes you are also interested to know the original indices. What I mean is, for example, let's say 5, right? What is the index of 5 in this array? In this array, what is the index of 5? Yes, 3. Okay, the index of 5 is 3 in this array. But sometimes you would like to know what was the index of 5 in the original array. So what was the index of 5 in the original array? Yes. So can we get that information? Yes, you can get that information. You have a method called argsort, argument sort, or argsort. This method will give you for x1, once you sort the elements of x1, what were the original indices. So here you see the sorted index. You see for 5 it is 0. It means in the original array 0 was the index for 5. Similarly, in the original array 1 was the index for 0. If you see here 0, index is 1. So similarly, you'll have the other information. So you can sort the array in NumPy, as well as you can get the indices or the argsort of the array. Any questions, any comments? All right. Now that is the sorting with respect to one-dimensional array. Now let us see how things get different when you have 2 dimensions or more. So that is the array in 2 dimensions. So I'm just going to say print numpy.sort x2. So if I just do it like this, just sort x2, this is what I will get. If you let us try to understand what it's doing. If you look at the column, here you have 572 and 032. So it means the numbers in the columns are being changed. Okay. Now if you look at this row and this row, yes, the numbers in the row are the same. You have 5033, 0335. So numpy.sort, without any much, it will sort the elements in a given row in a given row. So in row 1, the numbers are sorted. How? Column wise. So this is 0 moving to first column, then 3 move to the second and third column, and 5 move to the last column. Okay. But here it's not asking us, it's asking us to sort row wise. What is the meaning of row wise? It means for a fixed column, shuffle the rows. Okay. So it's not doing that. And now we see that things are different. Whenever you have array more than one dimension, so for example 2 dimensions or 3D or beyond, you have to specify the axis. You have to specify along which axis you would like to sort. So here when I say axis 0, it means it's saying that you are sorting it row wise. What is row wise? It means given a fixed column, for a given column, sort or shuffle the rows. So for column 1, I'm going to shuffle the rows. Okay, look at this now. For column 1, I shuffle the rows. So instead of 572, I have 257. Instead of 094, I have 049. So for a given column, I am shuffling the rows. That is the row wise sorting, and this is done by setting axis equals to 0. So now we know that there is an option called axis. By the way, if you want to know all the details of this method np sort, how to get it, how to get all the details of numpy.sort, yeah, you have to use this help, and please get familiar with this, because in the exam you are free to use it, and this is the best way to remember. Okay, so here it says you have one positional argument, which is a, and then you have keyword arguments, and among the keyword arguments you have axis, and by default the axis has an option of value of -1, which means it is the last axis. So if you have rows and columns, columns is the last axis. If you have a 3-dimensional index 3 by 4 by 5, then the axis corresponding to the 5 will be the, sorry, then the axis corresponding to 5 will be the default axis. Okay, so the default axis will be the last axis. So whenever you're doing sort, okay, you have to mention the axis. So the next question, question number 3, is the same thing, but it is asking us to sort column wise. So all it is asking us to change the axis from 0 to 1. Okay. Yeah, or axis -1 is also fine. In this case, you see columns are the last axis, so you could just leave it axis -1, or you can even skip the axis, because that's the default option. Okay, so yeah, you can have different values for axis to get the same result. Now you see this is column wise. Why column wise? Because if I fixed a row, you see numbers have been shuffled along the columns. Columns have been shuffled for a given row. So that's a column wise sorting. Any questions, any comments? Okay, if not, let us look at this array copying. Okay. Now the discussion here, it is almost similar to the Python, and NumPy is not bringing anything special. It is inheriting from Python, so nothing special here. Okay, so let us see what are the things that we are doing here. Yes, axis equals to 0 means it is sorting along rows. So for a given column, you sort along rows. So for a fixed column, let's say column 1, you shuffle the rows. That is the row wise. Okay. All right. So let us look at this copying concept here. Here I'm creating an array x2, and then I'm copying the array like this. I'm saying x2 copy, a new name, is equal to x2. So that's the assignment operator. So x2 copy assigned to x2. And then when I print it, I get a replica of x2, which is x2 copy. Then I am changing some of the elements of x2 copy. For example, here on the left hand side, can you tell me what is this slicing? What does it mean? Okay. Well, that's 0. The first 0 means 5033. That's right. But then you also have 1 3. What does it mean then? Okay. 033 035. Any other answers? So this first 0 means the first row, right? Everybody agrees this is the first row. Okay. Yes, this first 0 here, it means 1 3, right? Sorry. Let me start this. Okay. So this 0 here, means this, right? Is there anybody who has doubt on this? Okay. Now the question is, what about this 1 3? What is the meaning of this? This is for rows or columns, and the first one was for rows, so this should be for columns. So in the columns, I'm giving 1 starting from 1 and ending at 2, right? Just before 3. So what columns do you think are selected here? Yes, so now we got the right answer. So essentially what we got is just this 0 3, this array, and I'm going to replace those values by 4 4. So this value will become 4 and this value will become 4. Okay, that's what is happening in this line 11, and then I'm just printing it for making sure that it works the way it was supposed to be. And now you see these two numbers have been updated to 4 4. If you have mismatch in dimensions, you will get a mismatch error. Okay, if you have mismatch in direction, you get a mismatch error. Cannot copy a sequence of size 3 with dimensions 2. Now, let us try to print x2 and see what will happen. Oh, so this is x2 now. So what do you think has happened between x2 from the previous statement and this statement now? Yes, x2 got changed. But did we change x2? We didn't change x2. We changed x2 copy. We never changed x2. So why did this happen? Because, yes, because in Python, when you have mutable objects like list, when you have mutable things, the equal to or the assignment operator is doing a reference. It is creating a reference. It is not creating a new array. Okay, it is just creating a reference. Yeah, reference is like pointer, similar concept. So yes, so it is creating a reference. It is not creating a new array in this case. Okay, so how to actually copy it? Well, it's the same thing. Actually, it's the same thing coming from Python. This has nothing to do, not much to do with NumPy. So to copy a full array, like you used to copy full list, you have to write here dot copy. Then you will get actual copy. Okay, then you'll get a new actual copy. And now if you see, only x2 has changed. Sorry, only x2 copy has changed, but x2 is the same. It didn't change. Okay. So whenever you have to copy an array, please make sure that do you need to copy the array, or are you planning to come up with a new reference. If you're planning to come up with a new reference, the old style is fine. But if you're planning to come up with a new array altogether, then one of the ways is to use the dot copy method to copy the array. So you get two new arrays. So x2 and x2 copy are independent, two different arrays. Okay. This is same for the list as well. So if you have the Python list, and if you copy them without using dot copy, you will get the same issue. You will have things being repeated, in all the instances, because they are not real instances. They are different names referring to the same data. Okay. So that is about copying of array. Now you have a concept called reshaping. So sometimes, depending on depending on various reasons, you might have array of one shape. For example, here you have one row and I believe 9 or so many columns. Okay. Yeah, 10 columns, size 10. Yeah. Okay. So you have one row, 10 column, one-dimensional array, and for some reason you want to convert it. You want to convert it to a two-dimensional thing of given size. For example, I want to convert x1 to a two-dimensional array of 5 rows and 2 columns. So I could say x1 dot reshape 5, 2, and then I will get this 5 rows and 2 columns. Okay, 5 rows and 2 columns. So again, it's not changing x1. Okay, it is not changing x1. It is just for that time it is changing it. If you want to save it as a different name, or even if you want to save it as x1, you could do that. You could just say here, this is reassignment, which is I think the update kind of thing. So now if you look at x1, it is 5 rows and 2 columns. Right. Similarly, I should have not done that. Yeah. What is the size of the reshape? No, size will always be the same, right? This is a good question. I think I cannot do redo. So let me just put it here. See, what is the size? Size means the number of elements, right? So the number of elements will be the same. Okay, and then and both of them will have the size of 10 units. But what will change is the shape. Shape is number of rows and columns. Okay, so if you see here the shapes, now the shapes are different. One is a 1D array of 10 elements. The other one has 5 rows and 2 columns. So that is the change. Yeah. Now, if they are not corresponding, for example, let's say I have 10 numbers and I want to divide into 6 rows and 2 columns. Can I do this? Can I take 10 numbers and divide into 6 rows and 2 columns? Not possible, right? Because I need more. How many elements do I need to divide into 6 rows and 2 columns? 12. So it is not matching. And if that's the case, I will get an error that you cannot take 10 elements and reshape it to 6 by 2. Now, if you have 13, again, it will not do because it is more. If you have the exact match, only then it will reshape. Okay, I can just write here x1. Okay, if you have the exact match, only then it will reshape. And this is the reason why, when you have, let's say, size 12 and you want to break it down into rows and columns, you can keep one of them empty in the sense you can tell Python to pick the corresponding value. So for example, if I have 12 elements and if I say 6 should be the number of rows, what should be the number of columns? I have 12. Is there any other answer apart from 2? If I fix the number of rows to 6, there is no way, right? So that's it. So in writing -1 there is telling Python or telling NumPy to get the corresponding value here. So you don't have to compute the corresponding value, it will get it for you. Okay. Similarly, if I write here 4, what is the corresponding value? Yeah, and for sure there will be no other answer. Everybody will say 3. And this is exactly what it does. 4 rows and 3 columns. Okay. Let's say I divide it like this. 2 by 3 by something. Can you tell me what should be that something? Yes, it will be 2. So I have 2, 3 by 2. Okay, there is a question by Faisal. What if I had 2 possible? There is no way you will have 2 possible answers, Faisal. Okay, so if I give here 3, I have 12. If I give 3, what will be the other answer? It will be, Faisal? Yes, it will be 4. Yeah. So there is no way you will have 2 possible answers, right? And that's the reason why it is determined. Okay. Now, what will happen? Let us say if I give 2 minus 1, it will tell us that no, you cannot have more than one instance of -1. So if I have 2 minus 1, it says no, you cannot have 2 unknowns. You should have one of them fixed, either this or that. So you could have fixed this one. So 5, 12, it will not work. So it will say it will not work. But with 5 and let's say 4, it will work. Okay. So 3 rows and 4 columns. Okay. So this is how you can reshape. You can come up with any compatible matrix with compatible shape. Okay. Any doubts? Any questions? Did I clear your doubt, Faisal? Okay. Any other questions? Any comments? Okay. If not, then we move to concatenate. Concatenate and split. Now, sometimes you have arrays coming from various, functions or methods, and you want to group them, you want to join them. To join, Python gives you different options. One of the simple options here is concatenate. Concatenate, what it does, it takes the arrays. They should be in the compatible size. For example, all of them are one-dimensional arrays. So it takes them and just joins them one after the other. That's it. Okay. And what you get is the concatenated array. Okay, so X is here, then Y is here, then the Z is here. Okay. Sometimes you would like to concatenate in a particular style. Okay. For example, let's say I want X to be at the top, then Y here, then Z here. Okay. So you are stacking them vertically. So it's called as V stack. Sometimes you would like to join them horizontally. So X, Y, Z, like putting them side by side. So it is called as H stack, horizontal stack and vertical stacks. So here I could say, for example, H stack. Sorry, H stack is by default because it's 1D array. But if you see V stack, this is how it goes. Okay, 1, 2, 3, 3, 2, 1, and you could change the positions, and you could repeat it if you want, or you could change the positions, and it will do the stacking for you. Okay. That's the horizontal stack. You could also do combinations of horizontal and vertical, and here is an example of horizontal stack. So here I have array Y, which is 2 rows and 3 columns, and Z, which is 1 column. The number of rows here are 2, the number of rows here are 2. So now I could combine Y with Z. So Z could be like the first column, and Y could have the second, third, and fourth column. So I could use the H stack, not the V stack, right? It will not. The example is for H stack, and you can see that they are stacked. So Z is the first column is here, then the other ones, and you could also do this, and sometimes you could do let's say if you want to be, depending on the need actually, up to, let's say, H, yes, that's right, Hadi. H for horizontal stack and V for vertical stack. Okay. So yeah, you could put it in between. You could have many. Depending on the need, you can join different arrays. You can join different arrays. Okay. Also, you can split. For example, here is an example. You can split the arrays based on your need. For example, here is you have one-dimensional array, and you want to split, let us say, at these 3 points. So at index 3 and index 5. So you could execute this, and then you get two arrays. So 0, 1, 2, 3. So here's the first split. So 0, 1, 2, 3, 4, 5. So here's another split. So you have 1, 2, 3, 9, 9, 3, 2, 1. So there could be a reason why you have to split an array into so many splits. And if it is needed, then you have a method called numpy.split. Okay. Yeah. Any questions? All here it is a list. Here it is a list, but it could be array. The importance is this, that you have the numpy method that splits. Okay. It could split a list or it could split an array. Right now it is a list, but it could be array. But this is the method. The numpy method is the one that is splitting. And you see it also captures, for example, the first part is assigned to x1, the next part is assigned to x2, the next part is assigned to x3. And what I could do is I could have said x2 equal, because I know it has two elements, I could say 0, 0. And now you see it has become 0, 0. Okay. So if you have two or more dimensional array to split, you have to do it axis wise. Okay. And by the way, you have to use axis, like sorting. You have to use axis, and here, let us look at the uh, help. And here, the axis is the one that helps you in two-dimensional splitting. Okay. We can take an example. Actually, the example is given here. So let me just. Well, here there is only one-dimensional example. Let us do a two-dimensional example. Actually, we should have added in the slides also, maybe. So let us create a 2D array. Let's say x2. No, usually 2D is what we have. Okay, we never go in 3D. If you want to go in 3D, you must be doing some specific application like computer vision or TensorFlow. In our course, no, 2D is our is all what we look at. Okay, so let's say. Size. Okay. Now let us say print numpy dot split x2, and let us say I want to split, let's say, along the rows. Okay, and I will say x is equals 0. Okay. So it is not that neat. So maybe let's say a b. Okay. So I'm splitting at one point. It means it will give me two pieces, right? And let us print those two pieces and let us see. Still not clear. Yeah, now it is clear. So that's the original array. What I did, I split along row with index 1. So 0 1. So from 1 it will start splitting. Okay, so 0 is gone. So from 1, this is inclusive, right? In the previous example they were inclusive. So 0 1. So from 1 it will start splitting. Okay, so how do I know it's row wise? Because I set axis equals to 0. Now what do you think if I set axis equals to 1? What will happen? Column wise. So 0 1. So from here it will break. Okay, so I will get 9 4 4 6 4 3 4 4 and so on and so forth. Okay, so here if I do it, you see first column has separated and then everything else. By the way, I didn't fix the seed, so I got a different matrix, so the numbers have gone. Okay, but I could have fixed the seed and you would have the same matrix. So whenever you have more than 2, you have to specify the axis, along which axis, and you can do axis by axis only. So if you want to split along the rows and columns, first split along the rows and then take the result and then split along the axis, along the columns. Okay, so you have to do it one after the other. Is it clear, Hadi? Okay. All right, so we are done with the basics of, oops, what did I do? Okay. Yeah, we are done with the basics of usual NumPy things. Now we come to something very important. That's the vectorized operations. Now, of course, there are many. Let me just reset size. Okay. Now, there are many advantages of using NumPy RS, and the purpose was for numerical computations. But the power of the NumPy arrays are shown in the vectorized operations. For example, let us say you have, okay. For example, let us say you have a list. What will I get if I do this operation? What will I get in the list 1? I get all the numbers starting from 0 up to 9, right? And let us say for each of this number, I want to add +1. How to do that for each of this number? Yes. Then I should say here +1, right? But let us say I don't have this information. Can I use list 1 +1 and get this answer? And right now this is a list 1. What will happen if I say list 1 +1? If I say list 1 +1, he will say, what are you trying to do? Yeah. How about this? If I give list 1 plus this, if I give this, what will happen? Yeah. Now you add 1 here. So you're appending 1. So if you want to do any operation for all the elements of the list, yeah, if you want to do operations for all the elements of the list, you have to take each one by one and do the operation. Okay, yeah, you have to loop it. Yes. Now let us look at something. Let us look at the NumPy array. Now for the array, I'll do this. Let's say 2, or let's make it 1. What did it do? What did it do? Yes. So this is the power of NumPy arrays. You can do what we call vectorized operations. Okay. You can do, sorry, let me just bring it here. You can do vectorized operations. Okay. Vectorized operation. This is very powerful because you will not need loops. And remember, Python is slow because of the loops. The loops of Pythons are slow. So the more the loops you avoid, the faster your code will be. And also, it looks very short and compact. That is something nice. So if you want to add or subtract, or well, multiplying one doesn't make sense. So if you want to multiply 10, okay. Yes, you can multiply one, but it will not show the effect. Okay. So you can multiply by 10 or divide by 10, or if you do integer divide, it will make it true then. So you see, if you want to do operation on each element, you can do it in a single shot in Python. That is the power of Python. Okay, that's the power of NumPy array. That's the power of NumPy array. So here you see so many operations that you can do. You created a random array and you did addition, subtraction, multiplication, division, and the floor division, and all of them can be done without loop. Is this clear? Any doubts? Any questions? Yes, no? Okay. So what exactly is not clear, Mubarak? Okay, all right. Okay. Similarly, if I want to get the squares of each number, I could, if it is the list, I have to do it in the loop or while creation. But now you see, this will give me the square of all the numbers. Okay. This will give me the square of all the numbers. I could use any function, I could use any operation that I do it on single element and do it on the array, and it will do it for each element. So that is something that nice that you have for the NumPy arrays. Okay. Now, if I want to know which number is even or odd, well, I could just do modulo operator with respect to 2 to get the remainders, and if I do that, I get it for all the elements. I cannot do this for the list. If you remember, in the Python list, you cannot do these operations. Okay? But with the arrays, yes, you can do this. And this is something very useful. And you can see that you can save a lot of coding. By these vectorized operations. But it is not just compactness, it is efficiency, in the sense it is very speed. All these vectorized operations make the code much faster. Like, it will be very fast it will be similar to C programming sometimes when you do the vectorized operations in terms of speed. And in terms of coding, it will be very fast. For example, here is another case. Here you have an array, and you want to transform the array like this. So you take each element, divide it by 2, add to that +1, and then square, and then subtract, and then multiply it by -1. So exactly the same thing can be done here. Okay, minus x divided by 2 plus 1 square. So it did all of this in one single shot. Okay. So whatever is the equation, you can do it for every element. Yes, Osama?
What if I want to show just the numbers without array and data type?
Yeah, then you have this two lists, right? Sorry, two list is fine, but this, I think, maybe, yeah. Let us save it to, let's say, A equals, and by the way, why I'm using X, it should be array, right? That's a typo. And then you could say print a dot to list. Okay, so that those will be the numbers. Is this what you mean? Yeah, or in the previous case, I would have added the brackets. Yes, yes, you can use it for multi-dimensional arrays. So let us create a multi-dimensional array. Array 1 is numpy dot random dot rand int. Let us say you could have up to 20, and the size is 3 by 4. Okay. So well, it will be hard to compare, but we can do it. Okay, print array 1, and let me fix the randomness. Otherwise, you'll and this operation might be difficult, so I will just do simple. Okay, array 1 plus 1 square. Okay, this is easy for us to verify. So that is the 9, the first element. So 9 plus 1, 10, 10 square 100. So you should get minus 100. So 4, 4 plus 1, 5 square 25 minus 25. For example, here you have 8, it should be 9, and then 9 square is 81, and with minus sign, so it's here. Okay, maybe this time we don't have to do two lists, it will be maybe easy this time. See, so yes, you can do it for n-dimensional arrays as well. Is that okay? Is that clear? Okay, so all such operations are called as vectorized operations. These are a popular style of programming, which is very common for data science. And also, if you are a MATLAB or if you heard about MATLAB, it is also very common in there. Vectorized operations are very powerful. It looks like linear algebra. After a while, it looks like a linear algebra. Okay. Okay. So that is about the vectorized operations. Now, apart from vectorized operations, NumPy gives you what we call as universal functions, okay, or in short, UFuncs, or universal functions. What are those functions? Those functions are, vectorized wrapper functions. Let me just tell you what it roughly means. It means that you can apply the functions for all the values of the element. For example, you have absolute values, square root, minimum, maximum, and sum. Some of them maybe are repeated from your Python list, okay, but some of them may not be. Okay, for example, here you have absolute value of x. Not sure if we have similar. Do you have absolute value in Python list? If I want to make every element of this, how do you do that? You just write abs of list. Okay, so here, well, there are many functions, but here we have written some, and I realized just now that most of them are also one. But yes, there are many universal functions in NumPy that works on every element on every element of the array. Okay, of the array. So please remember that here the function that we took. Now it occurred to me that they might be also available on the list, but there are many other methods that you cannot. Okay, that you cannot execute on every element. Okay, so there are many functions in NumPy that can be used for every element of the array. Please remember that. Here you have absolute value. Here you have square root of absolute value. Square root of absolute. Then you have min max. These are the very typical ones. And the sum. Sum is just the sum of all the elements. Okay. Now this vectorized operations here, or the operations here that we see, how are they done? Most of them, they are done based on the rules of broadcasting. Okay. There is some concept called broadcasting that will be used for all these vectorized operations, that wherever they are involved. What's the idea in the vectorized operations? By the way, here you have seen the vectorized operation of a array and a scalar, right? Here you have X and array and scalar. And if you remember here, there in the history, yeah. So here, what we did array and a scalar, okay? Array and a scalar. We can also have vectorized operations of array and another array. Okay, you could have two arrays and you have vectorized operations. When you have two or more arrays with the vectorized operations, then they follow these broadcasting rules, the one that are stated here. Okay, let me explain you all those rules in a simple manner. Let's say if you have an array of size 1 by, let's say 4 by 3, and let us say you have an array of size 3, then 1 by 3, then they are compatible, because you see that if you see, this 3 and 3, they are compatible. So there is 4 here and 1. So what it does, it takes this array of 1 by 3. You can say same number of trailing indices. So if you look at the last indices, in two-dimensional case, yes, you can say same number of columns. Okay, but in general, if you have more dimensions, the last indices, last sum of them should be the same. So last sum of them should be the same. Okay. So in two-dimensional case, things are much easy. You have 2 by 2. So if the columns are same, then yes, you can broadcast it. So what it does, it looks at the rows. The one that has less number of rows, it takes that and duplicate and creates a new 4 by 3 matrix. How? Each row will be 1 by 3. Copy of this 1 by 3. 1 by 3. Let me write it here. 1 by 3. So it will make 4 copies of this. So it becomes 4 by 3. So you have 4 by 3, and then the other one was 4 by 3. Then it does all the element-wise operations. Okay. Then it does all the element-wise operations. Okay. If they are the same size, if both of them are same size, then there is no doubt about it. Okay. For example, here is the case. Here is the example. Okay, I should have erased it. So here in this example, you see you have array 1, which is X, and array 2, which is Y. So both of them have the same size. They are 1 row and 3 columns. Okay, 1 row, or you can just say one-dimensional array with size 3. Both of them are one-dimensional arrays with size 3. Because they have the same shape, we have the same shape. When you do sum X plus Y, it is taking the corresponding elements and adding it. For example, 5 plus 0, 5 plus 1, 3 plus 2. Similarly, if you want to do multiplication, it takes corresponding elements and do multiplication. For example, 5 multiplied by 0, 5 multiplied by 1, 3 multiplied by 2. Okay, so that is how it does. Okay, now for when the shapes are different, then yes, you have to think a little bit. So what do you mean same as matrix? Well, in matrix, plus is okay, but multiplication of matrices is a different thing. So multiplication is not same. You see here in matrix, matrix multiplication, it's a different concept in math. But here it is element-wise multiplication. All those operations are done element-wise. That's something to remember. So matrix addition is element-wise, but multiplication is different. Matrix multiplication is different. Okay. Here the multiplication is element-wise. Multiplication is element-wise. Is that clear? Okay. Now here you have a matrix and an array. Here you have matrix of 2 rows and 3 columns, an array of 3 columns, 1 row and 3 columns. Are they compatible? Okay. But just now we said that if the columns match, then they are compatible. So matrix 1 and array 1, they have the same number of columns, 3. So they are compatible. Okay. So if I do m plus a, what do you think will happen? Can anybody tell me? If I do m plus a, matrix plus this array, what do you think will happen? Yes. So this is, yes, exactly. That's right. Okay. So remember this. This is 2 by 3. This is 1 by 3. So if because it's 1 by 3, it will be converted to something like this: 0, 1, 2, 0, 1, 2, and then this. Okay. So it will be converted to 2 by 3. And then you add the corresponding elements. So 1 plus 0, 1 plus 1, 1 plus 2, 1 plus 0, 1 plus 1, 1 plus 2. Okay. And this will give me the final answer, which is 1, 2, 3, 1, 2, 3. Okay. What do you think will happen if I multiply? Again, the same thing, because it's 1 by 3. First, it will reshape, or make the copies to have the same shape, 2 by 3, and then the corresponding elements will multiply. So 1 multiplied by 0, 1 multiplied by 1, 1 multiplied by 2. Because these are all ones, in the end you will get this matrix. Okay, and this is okay. The end you will get this matrix. So that is how this broadcasting works. So broadcasting is easy, but also you should be very careful, because sometimes you don't want to broadcast. Sometimes there is an error. Sometimes when you are saying m multiplied by a, there is an error in the dimensions of a or m. But because they are compatible in broadcasting, NumPy did broadcasting for you. So you have to be very careful, because it's automatic thing. Sometimes you don't want it, but it will do it for you. Because of an error, it happened and it did it. So that error is hidden now. You cannot see. So it's not a syntax error anymore. And this could be an issue later on. It could be a logical error. So you have to be very, very careful with broadcasting. Okay. So that is something about broadcasting. Of course, there are many more details to broadcasting, but we have seen some basics of broadcasting. Okay. The last topic in the NumPy library is masking. Maybe just a couple of minutes and I'll stop. So in NumPy, with NumPy arrays, another advantage you get is you get an easy way to come up with conditions, easy way to check which elements of the matrix should be used, which elements of the matrix should not be used. What I mean is, if you have a list, okay, and now let us say I want to print only those elements that are more than 3. So I want 4 and 5. How to do that in the list? Anybody in the class? From the list 1, if I want to print the elements which are more than 3, how to print that? Or I would like to know which of the elements are more than 3. How to do that from the list? Yeah, I have to go with the loop, but not with the array. Okay, not with the array. So I will say which elements are more than 3. And if I do that, I get a new array. Can anybody explain me what are the things in this new array? Yes, these are true or false values. Okay, these are booleans, right? Booleans, the true or false values. This is an array. It says the first 3 are false. It means the first 3 elements, they don't satisfy this criteria. The last 2, it satisfies the criteria. Okay, so they are called as the booleans, a list of booleans. And that list of booleans is sometimes referred to as masked array. Masked array, okay? Masked array. Why is it? Where is it helpful? Well, I could say, for example, let's say I wanted to select the numbers more than 3. So if I create that mask and print the array, okay, this should be square, right? You'll see that you will get the corresponding value. So whatever mask you want, you can create, and you will see in the next class many conditions of it, many styles, many complicated conditions, and you will get in one single shot without any loops. You don't have to write masks separately. It could be like this, and now you get it. Okay. Yes. Masking, first you create a mask to differentiate what is needed and what is not. What is not is false, what is needed is true. And the mask, when you do this operation masking, it will consider only the true values. Yes, the values that have the true or satisfy the condition. Okay. So that's it. Let us stop here. We'll continue from here in the next class. If you have any questions, any doubts, please text on MS Teams. I will send a survey link today for the office hours. Also, for the quiz, it will be in the next Wednesday. Okay. But if you guys want to push it to the weekend, please think about it, discuss it in your class, and see. The material of the quiz is same as the material of the homework. Okay.
Doctor,
Yes.
what's the benefit of seed?
Seed, because this is a random matrix, every time you execute, you will get a new thing. Yeah, Hari, that's right. Python review and NumPy, that's right. So Osama, if you have a random matrix, for example, let's say here, I want to can you hear me?
Yes.
Okay. So if I use this, yeah, this is array 1. Let me print array 1. This is so if I want to do some computation later on and execute again, the numbers will change. So sometimes I want to fix the random numbers so that I could repeat the things, and maybe I could give the code to somebody else, and on his or her computer they want to repeat the things. So if that's the case, I would like to set a seed, some number here, and based on that number, you see all the time we'll get the same matrix. Okay, so that is the purpose of random seed. You fix the seed,
Okay.
then the random matrix that you get after that, it will not change. It will be the same every time. You change the seed, of course. If you change the seed, you will get a different random matrix. But whatever you get for 100, you will get the same. Whatever you get for 10, you will get the same. For 100, you get the same. Okay?
Okay. Thank you. Thank you so much.
Okay.